Hai, Assalamualaikum and Salam Sejahtera. Today we are going to learn about Chapter 11, Nuclear and Particle Physics. For the first subtopic, the title is The Binding Energy and the Mass Defect. For your information, the nuclear physics is the study of the protons and neutrons and the interaction that hold them together in a space. So, mass defect, which is delta M, is only occur in a nucleus, where its definition is the mass difference between the total mass of the constituent nucleons and the mass of a nucleus. In reality, the mass of a nucleus is always less than the total mass of its constituent nucleons. Okay, so to get the mass defect, we need to use the equation which is ZMP, which is the total mass of the proton, plus with the total mass of the neutron minus with the mass of the nucleus. So please take note that the mass of the nucleus is equals to the mass of the atom minus with the ZME, which is the total mass of the electron. So any attempt to separate the nucleons will involve them being given the same amount of energy. This energy is called the binding energy of the nucleus. So now we look at to the definition of the binding energy, where it is the energy required to separate completely all the nucleons in the nucleus, where the equation is given by EB equals to the delta MC squared. So the idea that mass is a form of energy comes from the theory of relativity by the Einstein, and the equation is also known as Einstein mass energy relation. There are two ways to determine the binding energy. Okay, for the first method is when using the formula of E equals to the delta MC squared, and you are required to find the binding energy in unit joule. You need to ensure that the delta M or mass defect mass in the unit kilogram multiply with the speed of light square. The unit conversion involved is for one atomic unit U, it is equals to the 1.66 10 to the power of negative 27 kilogram, and for 1 mega electron volt equals to the 1.6 10 to the power of negative 13 joule. Then for the second method, you also can find the binding energy in unit mega electron volt when you use the value of mass defect delta M in unit atomic mass unit multiply with 931.5 mega electron volt per C square. Okay, next is binding energy per nucleon, which is EB per A. So it is a measure of the nucleus stability. A nucleus is stable if the nuclear force is greater than the Coulomb force, or in other words, it becomes more stable if it has a greater binding energy per nucleon. So there are two types of forces involved in the nucleus, which are Coulomb force and attractive force, which is nuclear force, that bind all the nucleons together in the nucleus. So for your information, a nuclear force is the strongest force, short range, and does not depend on the charge. Let's say the interaction between the proton and the proton, neutron and proton has the same magnitude of the nuclear force. So we can find the binding energy per nucleon by using the formula of EB per A equals to the delta MC squared over A, where A is the mass number. The figure below shows a graph of binding energy per nucleon against nucleon number. So as you can see, the value of EB per A rises rapidly from 1 mega electron volt per nucleon to 8 mega electron volt per nucleon, with increasing mass number A for light nuclei. So for the nuclei with A between 50 and 80, the value of EB per A ranges between 8 and 8.9 mega electron volt per nucleon, and the nuclei in this range are very stable. Okay, the nickel has the highest EB per A, showing that the nickel is the most stable nucleus. So for heavy nuclei with A between 200 to 240, okay, the binding energy per nucleon is decreasing, shows that these nuclei are unstable and radioactive. Okay, let's do the exercise 11.1, page 25, question number 2. So the atomic mass of neon 20 is 19.99244 U. So calculate the binding energy per nucleon of neon 20 nucleus in mega electron volt per nucleon. First of all, you need to write down the value of mass of the neutron, electron and proton by looking at the list of selected constant value that are already given in physics book or in the question paper. So the atomic mass of the neon is already given in the question, which is 19.99244 U. Next is we have to calculate the proton number Z, which is 10, and the neutron number is 20 minus 10, which is equals to the 10. Since an atom consists of a nucleus and electrons, so we have to find the mass of the nucleus by minusing the atomic mass with the total mass of the electron. Hence, we get the mass of the nucleus as 19.98696 U. Then, find the mass defect of the nucleus by using equation of delta M equals to the ZMP plus with NMN minus with mass of the nucleus. Hence, we get the mass defect as 0.17244 U. To get the binding energy per nucleon, okay, which is EB per A, we have to find the binding energy delta MC squared divided by the mass number. So delta M is 0.17244 multiplied with 931.5 mega electron volt per C square per 1 U multiply with the C squared divided by 20, and you will get the answer as 9.03 mega electron volt per nucleon.